Here's a familiar story for you. Once there was an ape with a set of amazing hands. They were delicate enough to sift through pebbles in a stream, yet strong enough to curl into fearsome fists. It all comes down to our body schema, our brain's conception of our body's position in space. That's some pretty complex mental processing in and of itself. Our brains constantly process sense feedback to establish where our limbs are at any given moment.
But our friend the ape here benefits from higher cognition. When he first picks up his glorious bone club, the body schema takes a bit to update.
Dear ape man, this is your brain speaking. Your left arm is now a foot longer and hard enough to split a boar's skull.
Sharpen a stone and you have a simple reduction tool. Fasten it to a stick and you have a conjunction tool. Finally, propel it through the air with a bow and you have a linkage tool.
But our tool use grows increasingly complex.
The tool we call keyboards and joysticks allow us to interface with machines. Not only does the joystick become an extension of ourselves, but so too does a library of data, a video game character, or even a military drone. And we do it all with these deft little hands.
But science is already working to take these hands out of the picture. The human brain already learns to treat an artificial limb as part of the body, but soon prosthetic limbs will benefit from direct control by the brain itself.
A 2008 Duke University study allowed a monkey to control a robot via electrodes implanted in its brain. Then, in 2012, researchers at Brown and Harvard developed a prosthetic human arm that depended on electrical signals from the brain's motor cortex, allowing a paralyzed woman to pick up a container of coffee and drink it from a straw.
Between our brain's ability to adapt its body schema and science's ability to create mind-controlled tools, human tool use ascends from the concrete to the abstract. And where might this take us in the future?
Imagine a cybernetic bird soaring high above unscalable summits, the wind soaring across its body, all sensations experienced by a human in goggles and a brain cap.
Or envision the first human being to set foot on Mars, not a flesh and blood space traveler, but a robotic avatar controlled by an earthbound explorer's mind.
But even for brains as highly evolved and tool-friendly as our own, there must be limits. We might remotely control one Martian avatar, but could we also control the rover that landed it there and the ship that delivered it?
Scientists are already exploring ways to link two or more human minds in the performance of a single complex task. They won't actually share thoughts, but they will control the same mechanisms just by thinking about it.
A 2013 study from Duke University enabled two rats to share brains and sync movements, and soon humans may get in on the brain-bonded action as well.
A current University of Essex program aims to use brain-computer interface technology to give a pair of human pilots full control over a virtual spaceship, all with their linked minds. The plan calls for both test subjects to wear sensor caps and focus on 8 directional cogs to move the ship. Now, two linked brains still can't outperform a single human with a joystick on a task like this, but there's ultimately a tipping point.
Link up enough brains and a single human with physical control simply cannot keep up, especially as the task at hand becomes more and more sophisticated.
So here's another vision of tool use in humanity's not-so-distant future, a time when a dozen explorers link their brains to control a starship.
And then imagine 24 more brains linked together to command the creatures of steel that serve as our emissaries on a distant alien world.
So where does the tool end and the user begin?